Hello GATE aspirants. Welcome to part 4 of Electromagnetic Theory series. Question number 13. At a surface current, which one of the following magnetostatic boundary condition is not correct? Now we know del dot of B is equal to 0. So that means B perpendicular above, it will be equal to B perpendicular below. So normal component of magnetic field is continuous. So A is correct. And magnetic vector potential and electric potential. These two are continuous at the boundary. So option B is correct. Normal component of magnetic vector potential is continuous, and tangential component of magnetic potential, that will also be continuous. So the condition which is not correct is option D. Then question number 14. Interference fringes are seen at the observation plane z is equal to 0 by the superposition of two plane waves a1 exponential I k1 bar dot r bar minus omega t and a2 exponential I k2 bar dot r bar minus omega t, where a1 a2 are real amplitudes. The condition for interference maximum is. Now let us find out phase difference between these two. So phase difference will be subtraction of these. So this will be k1 minus k2 and dot product with r cap. Now if this phase difference is E1 multiple of pi, then it will be maxima. So it should be E1 multiple of pi. So option B is correct. If it is odd multiple of pi, then that will be condition for minimum. Next question. A circularly polarized monochromatic plane wave is incident on a dielectric interface at Brewster angle. Which one of the following statement is correct? Now circularly polarized light is combination of two plane polarized waves that are perpendicular to each other and have phase difference of 90 degree. Now option A is the reflected light is plane polarized in the plane of incidence and the transmitted light is circularly polarized. Now at Brewster's angle, the reflected light will have no parallel component because it is minimized to 0 at this angle. So it will leave only perpendicular component. So reflected light will have perpendicular component. Then transmitted light, which is refracted into the second medium, it will generally have both components, but their amplitudes may be different. So amplitudes can be different. So that means it won't be circularly polarized now, it will become elliptically polarized. So here option C is correct. Reflected light is perpendicular and transmitted light is elliptically polarized. Next question. A charge distribution has the charge density given by rho is equal to Q into delta of x minus x naught minus delta of x plus x naught. So that means from the boundary we have at distance minus of x naught charge. So this will be at minus of x naught, it will be minus q, and at x naught it will be q. So this is given to us. For this charge distribution, the electric field at 2x naught, so at this point we have to find out electric field. Now this is plus q charge, so electric field will be in this direction, and this is minus q charge, so electric field will be in this direction. So we have to calculate both. So this first, because of this positive charge, this will be kq by r square, and this distance, this will be x naught, because this point is x naught and this is 2x naught. So kq by x naught square minus second will be kq, because this is minus sign because of this negative charge, and this distance will be, this will be x naught plus x naught plus x naught. So that is 3x naught square. So this will be kq by x naught square, in bracket we have 1 minus 1 by 9, that is 8kq upon x naught square. And here we have to write value of k as well. So this will be 8 into q upon 1 upon 4 pi epsilon naught into x naught square. So this 4 can be divided, so this will be 2q upon pi epsilon naught, and 9 is also there, upon 9 pi epsilon naught into x naught square, and it is along direction x cap, so this will be x cap. So here option A is correct. 2q x cap upon 9 pi epsilon naught x naught square. Next question. A monochromatic plane wave at oblique incidence undergoes reflection at a dielectric interface if ki cap and kr cap and n cap are the unit vectors in the direction of incident wave. So this will be ki cap, reflected wave kr cap, and normal. Then which of the following expressions is correct? So we have these three. So if we consider ki cap cross n cap, so that will be, this vector will be perpendicular, this resultant will be perpendicular to this plane, and if we take dot product with kr cap, so then it will be 0 because this is perpendicular to kr cap. So here option C is correct. Otherwise if we check kr minus kr, they are in the same plane, and cross product with n cap, it may be or may not be equal to 0, we cannot say it for sure, but this option C will be valid always. Then we have next question, question number 44. In a constant magnetic field of 0.6 Tesla along the z direction, find the value of the path integration over a dl in the units of Tesla meter square on a square loop of side of length 1 by root 2 meters. The normal to the loop makes an angle 60 degree to the x-axis as shown in figure. The answer should be up to 2 decimal places. So this is given. So from here we can write using curl theorem. So this will be curl of A dot dA, and this will be on area S. But curl of A is B, so this will be surface integral of B dot dA. So this is equal to B into A, because B is constant here, so this will be B into surface integral of dA. So this will be BA cos theta. So this will be equal to B is 0.6 Tesla, area is, this is square loop, so area will be 1 by root 2 square into cos of, now the loop makes an angle of 60 degree with the normal. So that means this will be cos of 60 here. So 0.6 into 1 by 2 into cos of 60 is 1 by 2. So this is equal to 0.6 by 4, so that is 0.15. So answer is 0.15. So these were all the questions from GATE 2013 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.